In the previous movie, we simulated an ocean on the shoreline of this coastal town. In this movie, we'll give it more life by creating some gentle waves to crash up against the wharf. Make sure to set the current project to the provided scene folder, then open the file Coastal Town Part 2 Start. Play through the simulation to create a partial cache. Other than the initial settling motion, the water is quite still. However, the ocean isn't a still body of water. The wind, along with tidal forces, create waves. In order to create waves in our simulation, we could use one of two approaches. The first is to add a physical object, like a paddle, into our ocean to act as a collider and push the liquid around. An overview of this method can be found in the Maya documentation under the Bifrost Workflows section. Instead, for this movie we'll focus on using an accelerator. An accelerator is an object that Bifrost can use to influence the velocity of the liquid. In this case, our accelerator will be a polygon cube that will deform in a wave-like pattern over time. First, select the Bifrost node and go to its Bifrost Liquid Container tab. In the Liquid Solver attributes, turn off Enable for now. Create a polygon cube. Translate and scale it so that it roughly covers the surface of the ocean container currently hidden. Rename it Ocean Wave Accelerator Geo. In the attribute editor, increase the cube's subdivision width and depth attributes to 100. The higher these values are, the finer the wave deformation will be. Now, in order to get this plane deforming like an ocean surface, we'll shape the cube over time using a texture deformer. A texture deformer is a quick way to create procedural noise on an object using most types of textures. Select the accelerator object. In the animation menu set, go to Create Deformers, Texture Deformer. This adds a texture deformer node to your object, as well as a texture deformer handle object at the scene's origin. In the attribute editor, change the direction attribute to normal, since we want the deformation to run along the cube's UV normals. Maya automatically hides the handle object to reflect this change. To apply a texture, click the Map button next to Texture. In order to layer a few displacement effects on top of each other to drive the deformation of our accelerator, choose Layered Texture. Rename it Ocean Matte. For the first layer, click the Map button next to Color. We'll use Maya's 2D ocean texture to drive the primary shape of our waves. Rename it Wave Shape. Right now it doesn't look like it has much effect on our accelerator object, since there is not enough tone contrast. In the Wave Height section, increase the ramp point to 2 to make the waves taller. Then in the Wave Turbulence section, lower the ramp point to 0.1 to calm the waters. In the Ocean Attributes section, decrease the wavelength min and max attributes of each wave to 0.1 and 0.5 respectively to compress the wave's length, making them thinner. And set num frequencies to 2 to decrease the frequency variation across each wave. Now you can see some definite deformation in the cube. You can drag the time attribute slider to change the deformation over time. Notice that the waves run away from the shore though. You can flip this around by setting wind UV to -1, 0. The wave motion is now much closer to what you'd expect along a shoreline. It seems a little too regular though. Although waves flow in a primary direction, they're usually not this perfect. Since we're using a layered texture, we can add another layer of noise distortion on top of what we have so far. Click the Output Connection button to go back to the Ocean Matte tab. Click the empty space next to the current layer to create a new one. Middle drag this new layer to the left side of the original and set its blend mode to Add. Maya calculates the compound effect of layers using a right to left order. Click the Map button next to Color. This time we'll assign a noise texture. Rename it Wave Noise. Drag the Time attribute slider. The noise layer adds a cross wave that runs perpendicular to the primary wave. Set noise type to Wave to better match our existing wave distortion, and set num waves to 20. Also set depth max to 1 to reduce the amount of calculations performed on the noise distortion. At this point, we have a reasonable looking wave effect. However, if you scrub the time slider, it doesn't animate. This is because each layer of the texture deformer is controlled by a separate time attribute. Thus, we need to connect each of these individual attributes to the scene's global time in order to animate with the time slider. In the outliner, turn off Display DAG Objects Only. Select the Time, Wave Shape, and Wave Noise nodes, then open the node editor. Show the connections. The time node's outtime represents the passage of time in the scene. In order to drive both the shape and noise animation, we could connect this attribute to them directly. Instead, we'll connect them through intermediary multiply-divide nodes. These nodes will allow us to scale the effect of time, allowing us to control the speed and frequency of the waves and noise for further tweaking. Create the first multiply-divide node and rename it Scale Time Wave Motion Div. In the attribute editor, set its operation to divide and input 2 to 100 in the first X field. Connect the time node's outtime to this node's input 1x. Maya creates a unit conversion node automatically to convert the time type to a float type, which the multiply-divide node can understand. Connect its output x to the wave shape's time attribute. Repeat this procedure for the wave noise node, this time creating a scale time wave noise div that divides by 50. If you scrub the time slider, the accelerator object deforms over time. We're ready to drive the ocean velocity using this accelerator. Remember to first re-enable the Bifrost liquid solver from its Bifrost liquid container tab. Move the accelerator object down in the y-axis so its top surface roughly lies on the surface of your ocean. Now select both the Bifrost node and the accelerator object. Go to Bifrost, Add Accelerator. This adds the Bifrost acceleration section to the Accelerator Shape Nodes tab. Hide the accelerator and play the simulation to regenerate the cache again. Initially, the accelerator doesn't appear to have much of an effect because its default settings do not account for the ocean's size. Select the accelerator. In its Shape tab, go to the Bifrost Acceleration Geometry Influence section and increase influence to 100. This is a multiplier for the attributes in this section. Inherit velocity, which enables the movement or deformation of the accelerator to affect the liquid. Falloff bandwidth, which controls the falloff of acceleration around the accelerator. And direction magnitude, which controls the strength of acceleration along a specified direction vector. However, in this case we'll set the direction magnitude to 0, since we don't want any influence other than the inherited velocity from the deforming cube. If you rewind and play the scene, you can see that the accelerator now has a visible effect on the water. You could even increase the influence value further for stormier seas. The more dramatic you make the waves, though, the more likely it is a few particles will splash out of the container. This can cause performance issues since Bifrost still calculates the liquid outside of the area of interest in our scene. To make sure this doesn't happen, we can create a set of kill planes around our container. As the name suggests, these planes remove any liquid that crosses them from our simulation. Disable the simulation temporarily again, so Maya doesn't continuously recalculate the cache. To create a kill plane, select the Bifrost node and go to Bifrost, Add Kill Plane. Move and rotate the new plane so it rests against the side of the container. You can scale it to better define this border visually, though it's important to note that the plane goes on infinitely. Create 4 additional kill planes around each of the container's remaining sides, and along the bottom as a precaution. Hide these planes once you're done. Now particles are guaranteed to stay in the area you've designated. Re-enable the simulation. As we've seen so far, this type of liquid simulation can affect performance based on its accuracy and complexity. In the next movie, we'll push this scenario even further and create a more dramatic tidal wave effect, then show how to properly use caching to avoid the performance hit during playback.